pretty sure I'm going senile. I started to test and started working this first problem, and then I realized I hadn't started the recorder. Today's my birthday, and I suppose I'm one more year closer to being in a nursing home, drooling on myself. Anyway, let me say what I said again. I puzzled over which answer this was, whether it was B or C, because they looked the same to me. 38 to 55. Let me bring it up. So 38 to 55, and then I looked at this one, 38 to 55, and I'm sitting there, well, they both are the same. But take a look at this. See how there's more blue on this side of the dotted line? The dotted line represents your mean. So there's more on this side, toward the 38. On this one, there's more toward the 55. And so that's the difference between the two. Well, my mean is 45. The mean is exactly in the middle, the dotted line. So the difference between 45 and the small part of my shading, which is 38, would be 7. And the difference between the 45 and the 55, the larger part of my interval, would be 10. So the larger part should be on the right side. That's why I chose B. Okay, so we're going from 38 to 55. So I drew my picture here. 38 to 55 shaded in between. And we'll do normal CDF, 38, 55, the mean, the standard deviation. And that gave us 0.4539 when plugged in the calculator. And how I got that is I did second vars, chose normal CDF, put in 38, 55, 45, 14. That gives us our answer. Okay, so let me do next question. Okay, the incubation time for a type of fertilized egg kept at 100.7 degrees is 20 days. Suppose the incubation time is approximately normal with a standard deviation of 1 day. Okay, so what you're telling us, let me start a new page here. They're telling us the mean is 20 days, so 20. And our standard deviation, sigma, they say is standard deviation of 1 day. Now, A says, was probably a random selected fertilized egg hatches in less than 18 days. Okay, so here we got 18 less than is shaded this way. Clear over here is negative E99. So we'll do normal CDF, negative E99, 18, our mean, our standard deviation. The way it always works is our shaded area. The first part on the clear to the left is what goes first, and then what's to the right goes next. So I got second vars, choose normal CDF, negative E99, so negative second, 99, 18, 20, 1. Enter. That gives us 0.0228. 0.0228. The probability that a random selected fertilized egg takes over 22 days, excuse me. That was A. B, over 22 days. Well, here's 22. Over would be shaded this way. And clear over here is E99. So we'll do normal CDF, 22, E99, the mean, the standard deviation. So do second vars, choose normal CDF, 22, second, 99, E99, 20, 1. Excuse me. 0.02. That doesn't leave me feeling real good. 28. Negative E99, 18, 20, 1. 22, E99, 20, comma 1. Huh, interesting. So 0.0228. Probably a random selected fertilized egg is between 19 and 20. Hopefully this doesn't come out the same. 19, 20. Between is shaded this way. So we'll do normal CDF. 19, 20 our mean, and then our standard deviation. So do second vars. Choose normal CDF. 19, comma 20, comma 20, comma 1. 0.3413. 0.3413. So 0.3413. Would it be unusual for an egg to hatch in less than 17 days? Why? Less than 17. Well, that means we got 17 here. Less than is shaded to the left. And this is negative E99. So we'll do normal CDF. Negative E99, comma 17, comma our mean, comma our standard deviation. So do second vars, choose normal CDF. Negative E99, comma 17, comma 20, comma 1. Enter. 0.0013. So 0.0013. So what it would be unusual is the probability is less than 5%. 5% is your cutoff. If it's less than 5%, then it's considered unusual. So let's say next question. Let me open my window here. Oh, get some air going in. There we go. Problem number 3. The number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed with a mean of 1252. So mean is 1252. With this and standard deviation 129. A. Probably a random select bag contains between 1100 and 1500. Between 1100 and 1500. And we're shading in between them. And it says a random selected bag, so that's one bag. So we'll do our normal CDF, our low value, our high value, and then our mean, and then our standard deviation. So do second vars, choose normal CDF, 1100, comma 1500, comma 1252, comma 129. Then press enter. 0.8534. So 0.8534. Okay, number B. Probably a random select bag contains less than 1100. Here's 1100. Less than be shaded this way. And we've got negative E99. It's talking about a bag, or a random selected bag. So it's just our normal CDF. Negative E99, and then 1100, and then our mean, which is 1252, and then our standard deviation, which is 129. So do second vars, normal CDF, negative E99, so negative second comma 99, comma 1100, comma 1252, comma 129. Enter. 0.1193. So 0.1193. Proportion of bag contains more than 1200. Proportion is another word for percentage, for proportion, for probability. All those are the same. More than 1200. So I'm shading to the right. So we're going to do normal CDF, 1200 E99, our mean, which is 1252, and our standard deviation, which is still 129. And we're still talking about the proportion of bags contain more than 1200. So it's just our normal. So do second vars and normal CDF, 1200, comma, second, comma, 99, comma, our mean, which is 1252, comma, our standard deviation, which is 129. 0.6566. So 0.6566. 0.6566. Okay, a bag that contains 1,050 chocolate chips. It's 1,050. Now, when they're referring to percentile, they're referring to this area to the left. So it's just a different way of saying that. So normal CDF, negative E99, comma, 1050, comma, our mean, which is 1252, comma, our standard deviation, which is 129. So do second vars, choose normal CDF, negative E99, comma, 1050, comma, 1252, comma, 129, 0.0587. Round to the nearest integer. Okay. Well, that's going to take us to 5.87%. And nearest integer would be 6. So the 6th percentile. Okay, next problem. Number 4. The mean incubation time is 19 days, so mu is 19. Suppose the incubation times are normally distributed with a standard deviation of 1 day, so sigma is 1. Determine a 16th percentile for incubation days. 16th percentile. That means your value is more than 16% of the data, so this is what we're trying to find. If that's 16%, this is 84%. They have to add up to 100. Now, to find a value, like they're asking, we're going to use InvNorm. And your first parameter is always your area to the left, which is 0.16. Then our mean, which is 19, and our standard deviation, which is 1. So do second vars, choose InvNorm, 0.16, comma, 19, comma, 1. And round to the nearest whole number is needed, so it'll be 18. Okay. B. The incubation time makes up the middle 39%. So what you're telling us is the middle part is 39%. Now, if 39% is in the middle, then we got 61% in tails. If you divide that by 2, that gives you 30.5%. What am I doing? should probably go to sleep. Let's try it again. I said it, but I didn't write it. Divide by 2 gives us 30.5%. So here will be 0.305, and this will be 0.305. And we're trying to find out these values right here. This one is going to be InvNorm, then area to the left, which is 0.305, comma, our mean, comma, our standard deviation. Now this one will also be InvNorm, and it's the area to the left, which is the 0.305 plus the 0.39. And that gives us 0.695, comma, our mean, comma, our standard deviation. So I'm going to do second bars, choose InvNorm, 0.305, comma, mean, which is 19, comma 1, and that would be 18 to the nearest whole. Then the other one, we'll do second vars, choose InvNorm, and we got 0.695, comma the mean, comma standard deviation, and we get rounded B20, so 18 to 20. Let's say next question. Okay, I'm gonna grab a drink here. Let's take a look at number 5. A certain flight arrives on time 75% of the time. Suppose 186 flights are randomly selected. Use a normal approximation of the binomial to approximate the probability of exactly 140 flights. Exactly 140. Well, here's 140. When we're talking about the normal approximation of the binomial, then you have to do the 0.5 correction. And when it's exactly one value, you have to subtract 0.5 and you'll add 0.5. Then you shade what's in between them. The idea behind it is if your wording includes the number, see how exactly 140? That includes 140. So if your wording includes a number, the shading should include a number. Now this will be normal CDF, comma, our low value with the 0.5 correction, so 139.5, our high value with the 0.5 correction, and then we're going to have n times p. N is 186, and p refers to the percent on time, which is 75%. So that'll be 186.75, comma, square root of n times p times 1 minus p. So we'll have 186 times 0.75 times 1 minus 0.75. Okay, so do second vars, choose normal CDF, 2. We got 139.5, comma, 140.5, comma, 186 times 0.75, comma, second x squared, 186 times 0.75 times, beginning parentheses, 1 minus 0.75, which is 25%. Enter. 0.0672. So 0.0672. Okay, now this one is probably x is greater than or equal to 140. Here's 140, and we're going to subtract 0.5. And then shade to the right. Go over here is E99. Reason why we did that? our wording includes it, at least 140, and it tells you down here x is greater than or equal to 140. So the wording includes 140, so our shading has to include 140. If I added 0.5 and shaded to the right, my shading would not include 140. So this would be normal CDF, 139.5, comma, E99, comma, and then our other two parameters are the same. So we got 186 times 0.75, then the square root of 186 times 0.75 times 1 minus 0.75. You should be able to bring up previous entry. If I do a second enter, I bring up previous entry. And 139.5 is okay. But 140.5, I'm going to change that to E99. So I do second comma, 99, delete, delete. Okay, so 139.5, comma, E99, and then the other two are the same. So press enter, and it rounds to 0.5. 0.5. I don't think I need to put zeros, but just in case. Okay, probability x is less than 130. Here's 130. Less than. And this up here says fewer than 130, but it doesn't include 130. So, and less than shade to the left, so I'm going to subtract 0.5. Again, if your wording doesn't include 130, your shading shouldn't include 130. Less than 130 doesn't include it. So then we'll do normal CDF, comma, or negative E99, comma, 129.5, and then the other two parameters are the same as the parts A and part B. Okay, so I'm going to do a second enter to bring up previous entry. Change 139.5 to negative E99, so negative second comma 99 comma 129.5. And then I'm going to do a second delete to throw it in insert mode, put a comma, and then we got 186.75. Okay, everything else looks okay. Press enter. So our answer is 0.0452. 0.0452. Okay, let's look at this last one here. It says between 130 and 140 inclusive. Means it includes 130 and 140. Or 134, sorry. Well, I'm going to subtract 0.5 here, and I'll add 0.5 here. And then we shade in between them. Now, our wording includes, that's what inclusive means, our wording includes 130 and 134, so our shading should include it. If I had done it any different, like if I had added 0.5 here, this would be 130.5, and then if I shaded in between, well, our wording included 130, but our shading didn't. That's why we knew we had to subtract. Okay, so then we'll do normal CDF, 129.5, comma, 134.5, comma, and then the third and fourth are the same. So I'm going to do a second, or what am I doing here? Second mode, exit out. And press clear. Okay, second enter. And this is 129.5, 129.5, comma, 134.5. 134 point, now throw in insert mode, second delete, 5, and then enter. 0.1534. And I'll go to the next question. Okay. This is another normal approximation of the binomial. That's that 0.5 correction that we've been doing. And the different parameters here. N times p and n square root of n times p times 1 minus p. Grab a drink here. That's weird. It says time limit 90 minutes, but time isn't going at all. I don't know what that means. Kind of like that snafu down at Walmart where they're letting people with a vision card get as much food as they want. There was no limit for a while on some of the Walmarts. They were happy. I could get to $2,000 worth of food. In studies for medication, 13% of patients gain weight as a side effect. Suppose 473 patients are randomly selected. Use a normal approximation to the binomial to approximate the probability that, okay, 13%. That'd be our little p. And n would be our 473 patients. Okay, part A. Exactly 38. That means it includes 38. So we're going to subtract 0.5 and we'll add 0.5. Because if your wording includes it, then your shading should include it. And this will be normal CDF, our low value, which is 37.5, our high value, which is 38.5, our mean, which is n times p. So we're going to have 473 times 0.13, then comma, and then the square root of n times p times 1 minus p. So we're going to have 473 times p, which is 0.13, times 1 minus p, like that. Okay. So do second vars, choose normal CDF. 37.5, comma, 38.5, comma, 473 times 0.13, comma, square root, so second x squared, 473 times 0.13, times, beginning parentheses, 1 minus 0.13. Enter. That's kind of a strange answer. 37.5, 38.5, 473 times 0.13, yeah. Square root of 47 times 0.13 times 1 minus. Okay, now how do you interpret that? That's 3.16 e to the negative 4. This is scientific notation. It means I moved my decimal place 4 places to the left. So 1 there and then 3 zeros. So that's what equal to. And then rounded to 4 decimal places. That'll be 0.0003. So 0.0003. Okay, part B. X is less than or equal to 38. Here's 38. I'm going to add 0.5. Less than or equal to is shaded this way. Now our wording included the 38. That's a less than or equal to. Since our wording included 38, our shading has to include it. Clear over here is negative E99. So we'll do normal CDF, negative E99, comma, 38.5, comma, our mean and our standard deviation, which is the same as part A. So I'm going to do second enter, bring up previous entry. Change 37.5 to negative E99. So negative second comma 99 comma 38.5, which is what I already have. Press enter. And this would be 8.36 e to the negative 4. So we move our decimal place 4 places left. That'd be 0.0008 is our answer. This one's x is greater than or equal to 73. Greater than or equal to. Well, that implies it includes 73. So I'm going to subtract 0.5. Again, we're shading to the right. Again, if your wording includes 73, your shading has to include it. And then we'll do normal CDF, 72.5, E99, comma, our mean, comma, our standard deviation. So do second vars, choose normal CDF, 72.5. What am I doing? Go back to bed. Second enter. There. I don't want to retype all that. So I'm going from 72.5, comma, E99. So second, comma, 99. Now press delete to get rid of that 5. And then press enter. So we got 0.0661. Next one's going from 38 to 83, inclusive. So 38 to 83. Inclusive means includes them. So I'm going to subtract 0.5 here, and I'll add 0.5 here. And shade in between them. Again, if our wording includes 38 and 83, our shading has to. So then we'll do normal CDF, 37.5, comma, 83.5, comma, our mean, comma, our standard deviation. So I'm going to do second enter, bring up previous entry. And 37.5, comma, 83.5. And then second, delete for insert, put a comma. 473 times, okay, the rest of it's fine. So I press enter. And we get 0.9982. So 0.9982. Next question. Grab another drink here. Okay, suppose the tablet sometimes hangs up. There we go. What am I doing? Where's my test? Here it is. Suppose the length of pregnancy of a certain animal are approximately normal is with a mean of 152. So mean is 152. And standard deviation of 9 days. So sigma is 9. Now A. What is probably a randomly selected pregnancy lasts less than 149 days? Here's 149. Less than goes this direction. So this will be negative E99. Now this is just our normal CDF since it's A pregnancy. So we'll do normal CDF negative E99 comma 149 comma mean, which is 152, comma standard deviation, which is 9. Now let me go ahead and do the setup for the rest of these two. B. What is probably a random sample of 17 pregnancies has a mean gestation period of 149 days or less? Picture is still the same. 149 or less, so it goes this way. Negative E99. We'll have normal CDF, negative E99, comma, 149, comma, our mean, comma. Now part A says, what is probably A randomly selected? A randomly selected. We're talking about 1. B says, what is probably a random sample of 17 pregnancies? We're talking about many. So many pregnancies. Well, the many is where you take your standard deviation, which is 9, divided by a square root of however many you have. We got 17 pregnancies, so that'd be square root of 17. C. What is the probability that a random sample of 59 pregnancies had a mean of 149 days or less? Still the same picture, 149, shaded to the left. Here's negative E99. This will be normal CDF, negative E99, comma, 149, comma, our mean, comma, our standard deviation divided by a square root of how many we have. We have 59 pregnancies. So that'd be square root of 59. Okay, so second bars, normal CDF, negative E99. What's that? Negative second comma 99 comma 149 comma 152 comma 9. When I'm typing in things wrong here, it doesn't leave me with a good feeling. So that'll be 0.3694. So 0.3694. I'll bring up previous entry, so I'll do second enter. And you'll see these are pretty much the same. First parameter is the same, second one, third one, last one. Instead of just 9, we have divided by square root of n. So this is going to be divided by second x squared and 17. And that gives us 0.0847. Now next one is 9 divided by square root of 59. So I'll do second enter, bring up previous entry. And I'll right arrow over, and instead of 17, I'll put 59 in there. And press enter. 0.0052. So 0.3694, 0.3694, 0.0847, 0.0052. Now say next question. A. B, C, D, E. Quite a few parts of this one. Excuse me. Of course, I got unlimited time. I still got an hour and 30 minutes left. That's not working right. Reading speed of second grade students in large cities approximate normal with a mean of 89. Mean of 89. And a standard deviation of 10. So standard deviation is 10. A. What is probably a randomly selected student? A randomly selected student. We're not talking about many. We're talking about one. So we're talking about one student who read more than 93. Okay, here's 93. More than is shaded this way, which is E99. This is just our normal CDF. 93, comma, E99, comma, the mean, comma, the standard deviation. So nothing special there. So second bars, normal CDF, 93, comma, second, comma, 99, to put E99, comma, 89, comma, 10. And press enter. 0.3446. 3446. 0.3446. B, what is probably a random sample of 13 results in 93 or less? So we're no longer talking about one, we're talking about many. Still the same picture. Did I say 93 or less? Where my eyes are going. More than 93. So we're still shading to the right. E99. So we'll do our normal CDF, our low value, our high value, our mean, which is 89, and our standard deviation divided by the square root of n. And we're talking about 13 second grade students. So square root of 13. So do a second enter, bring up previous entry. Now do divided by second x squared for the square root, and 13. Press enter. 0.0746. 0.0746. 0.0746. What is probably a random sample of 26? More than 93, so same setup. So we got 93, shading to the right, E99, and then we've got normal CDF, 93, E99, our mean, and then our standard deviation divided by the square root of n. And we're talking about 26 second grade students. So this will be square root of 26. So I'll do a second enter, bring up the previous entry. And I'll go over to the 13, I'll put in 26. 0.0207. 0.0207. 0.0207. There we go. What effect does increasing the sample size have on a probability? You see how it's going down? This is 1, 0.3446. This is 13, that's 0.0746, and this is 26, which is 0.0207. So increases sample size, decreases probability. Decreases probability, decreases, so it's not the bottom two, so it's top two. Okay, so decreased probability because sigma increases as n increases. Because sigma decreases as it increases. It's B. Now, if you're wondering, well, why? Well, as I put larger and larger numbers in here, then the bottom part becomes larger. Well, if I start out with 1/2, for example, if I put 1/4 there, I put 1/10, I put 1 over 1,000. Well, as this number on the bottom becomes larger, then this number becomes smaller, which is what this is saying. Because as sigma decreases, because sigma sub x bar decreases as n increases, so it's B. Okay. Teacher instituted a new reading program. After 10 weeks, has found that the mean reading time of a sample of 20 second grade students was 91. What might you conclude based upon this result? Okay, mean reading rate of 91.5 is not unusual since probability of obtaining a result of 91.5 or more. This is part E. 91.5 or more. So I'm shading this way. E99. So do normal CDF. 91.5, E99, our mean, which is 89, comma, our standard deviation divided by square root of n. And we're talking about 20 second grade students, so that'll be a square root of 20. So do second vars, choose normal CDF, 91.5, comma, second comma for the E, and then 99, comma, 89, comma, 10 divided by square root, so second x squared of 20. And that gives us 0.1318. 0.1318. is not unusual. Unusual would be less than 5%. Okay, so it's not unusual. More is 0.1318. Okay, next question. I hope I get 100% on this. I don't want to go back and fix any of these. Mondays, I'm always tired for some reason. It's not like I go out and party. I think I'm just old. According to a study conducted by a statistical organization, a proportion of Americans who are satisfied with things are going in their lives is 0.82. According to a study conducted, okay, suppose a simple random sample of 185. Describe the sampling distribution of p hat. This looks like section 8.2. So let me bring up the PowerPoint for that. It's not as clear cut as the other ones. Okay. Now, when they talk about the sampling distribution, they're talking about finding the mean and the standard deviation. See how it says it's approximately normal with mean is equal to this, sigma is equal to this. Now, for us to use the normal approximation, n times p times 1 minus p is going to be greater than or equal to 10. So we'll verify that first. But let's see what they give us. According to a study, the proportion of Americans who are satisfied with things are going in their lives is 0.82. That's going to be our p. If I can get back to my whiteboard. There we go. P is equal to whatever I just said, 0.82. N, suppose a random sample of 105 Americans. Now, for us to do this approximation, then the I shouldn't say approximation. It's not the 0.5 correction. I don't want you thinking that. It is taking something that involves n and p, like proportion, and using normal for it, but it's not exactly the same as the other. So n times p times 1 minus p has got to be greater than or equal to 10 in order for it to be normal. Well, n was 105 times p, which is 0.82, times 1 minus p, so 1 minus 0.82. Let's see what that equals. 105 times 0.82 times, beginning parentheses, 1 minus 0.82. 15.498. Okay. Which is greater than or equal to 10, so it is normal. I just wanted to verify that. I was pretty sure it was. Okay, mean is going to be p. So mu sub p hat is going to be equal to p, which is 0.82. Sigma sub p hat is going to be equal to this formula, square root of p times 1 minus p divided by n. So p was 0.82 times 1 minus 0.82 divided by n, which is 105. Let's see what that gives us. So do second x squared 0.82 times, beginning parentheses, 1 minus 0.82. I'll put a closing parentheses there. Time, or divide by 105. So divide by 105, enter. And what's this say? If I can get back to there. 1, 2, 3, 4, 5, 6. Looks like 6 decimal places. Boy, I'm having a little trouble here. There. 0.037 493. Okay. 0.037493. Looks like this one. Okay, B. What is probably at least 82 Americans in the sample are satisfied with their lives? Probably at least 182 Americans are satisfied. I'm not sure about this. This is going to be kind of a touch and go. Let's put at least 182. So we got x is equal to 82. At least implies I'm shading to the right, like this. Over here is E99. Okay, find probability. These are going to be our steps. Our first step, find the mean and standard deviation. We just did that. They had us do that in part A. When I said this is going to be touch and go, I rounded this to 6 decimal places. In the perfect world, you wouldn't round it all when you plug it in your calculator. You round it to very end, not in the middle of a problem. But we'll go with this. I'm assuming that since they had 6 decimal places, that's what they want us to use. Okay, step 2. Convert the value you're working with to a z-score. Round z-score to 2 decimal places. So our formula is z is equal to p hat minus mu sub p hat over sigma sub p hat. Now I may be looking at that and say, well, we don't got p hat. Well, remember, p hat is equal to x over n. And for this part, x is 82, and n I have no clue. What was n? N was 105. (82) divided by 105. So I got 82 divided by 105. Geez, look at all those decimal places. I'm not going to round it. Again, you shouldn't round in the middle of the problem. So I'm going to just put in 82 over 105 for the p hat, minus mu sub p hat, which is 0.82, all over sigma sub p hat, which is 0.037493. It's actually a few more decimal places, but that's what they do. Now, on a fraction, if you have more than a single number or a single variable on top or bottom, you have to put parentheses around it. So I'll plug this in, I want to put parentheses on the top. Bottom I don't need to because there's only a single number down there. So let's see what that gives us. Do beginning parentheses, 82 divided by 105 minus 0.82, close parentheses, divided by 0.03 7493. Enter. 2 decimal places would be negative 1.04. Now what our picture looks like now is it's no longer x equals down there, it's z equals negative 1.04. And we're still shading to the right, that never changes. So then step 3, you have to figure out which one to use. Well, the one that goes to E99, that's shade to the right. The one that goes to negative E9 is the one shaded to the left. The one with Z1 and Z2 is when it's shaded between 2 values. So this one's shaded to the right. So we're going to use normal CDF, then our negative 1.04, comma, E99, comma, and tells us use 0 and 1. Now you might be sitting there and saying, well, geez, why'd you round it 2 decimal places? You know, that in theory, you know, we should be able to take it to however many we're given. You don't want to round in the middle of the problem. You just said that. Well, our tables in the back are based upon 2 decimal places. It goes to the hundredths in the table. Actually, in some problems, you may get 3 decimal places because remember in the table, if you've looked at it, if it's between 2 values, you can take it out instead of negative 1.04, it'll go out to negative 1.045. So it's a little bit tricky trying to get your answer to match exactly. Actually, if you use all the decimal places you see for the z-score over here, if you use all those decimal places, your answer is more accurate in the books. Okay, let's plug this one in. So do second bars, normal CDF, negative 1.04, comma, we're going to E99, so second comma 99 comma 0 comma 1. Enter. And that gives us 0.8508. 0.8508. 0.8508. 0.8508. Okay, C. What is probably that 79 or fewer? Let me get a drink here. $79 or fewer. Well, what they're implying here is X. And we need to do the z-score to change it. So our z-score is equal to p hat minus mu sub p hat over sigma sub p hat. Now p hat is equal to x over n. We already indicated that. For this particular problem, our x is 79. And our n from up above was 105. So this will be 79 over 105 minus mu sub p hat, which is 0.82, over sigma sub p hat, which is 0.037493. Now again, when we plug this in, we'll put parentheses on top. If you have more than a single number or single variable on top or bottom, you have to put parentheses around it. So that's how we're going to plug it in. So I do a beginning parentheses and 79 over 105 minus 0.82 close parentheses divided by 0.037 493. Enter. And two decimal places, we've got negative 1.80, like that. Now what our picture now looks like is instead of x equals down there, we got z equals negative 1.80, and we're still shading to the left, and clear over here is negative e99, which matches our second form, negative e99 comma z comma 0 comma 1. So this will be normal CDF, negative e99 comma negative 1.80 comma 0 comma 1. So I'm going to do second vars, normal CDF, negative, second comma for the e99 comma negative 1.8 comma 0 comma 1. Then we've got 0.0359. 0.0359. If I can get back to where I need to be, 0.0359. Next question. And last question. Okay. This is another 8.2 looks like. I can tell because see the sigma p sub p hat and sigma sub p hat, that's the only section that has those in there, so that's why I knew it's the last one. Okay, let's see what's this say. Describe the sampling distribution. According to survey in the country, 17% of adults do not have any credit cards. So they're telling us P is 0.17. Suppose a simple random sample of 300. So N is 300. Well, let's first verify that it's normal. We come up here, we want to check N times P times 1 minus P, make sure it's greater than or equal to 10. So we got N times P times 1 minus P. So we got 300 times 0.17 times 1 minus 0.17. Let's see what that gives us. 300 times 0.17 times, beginning parentheses, 1 minus 0.17. Enter. 42.33. Definitely greater than 10, isn't it? This is if it's greater than or equal to 10. Well, it's not equal, but it's greater than 10. So it's normal. Okay, so the mean is equal to P. So mu sub P hat is equal to P, which is 0.17. Sigma sub P hat is equal to square root of P times 1 minus P over N. This is formula here. Well, P is 0.17 times 1 minus 0.17, or 0.83, divided by N, and N is 300. Okay, so we'll do second x squared. We got 0.17 times, beginning parentheses, 1 minus 0.17, closing parentheses, divide by 300. And press enter. I'm going to assume 6 decimal places again, since that's what the last problem was. 0.021, 687. I guess I should have read the problem. Okay, so n times p times 1 minus p is less than 10. That ain't true. It's greater than or equal to, so it's not this one or this one. So it's either going to be B or D. And it's approximately normal. N is less than or equal to 5% of your population. Well, according to a survey in a country, 17%, and then it says suppose a random sample 300 adults is obtained. We assume that N is less than or equal to 5% of your population. Doesn't say how big of a country, does it? I mean, if you have 350 adults in your country, then this wouldn't be true. But we assume that's true. Okay, the mean. What did we just say the mu was? Mu was 0.17. And of course now they're switching. Sigma, they want us to round to 3 decimal places. Nothing like consistency. 0.022. I'll quit whining someday. I suppose when I die. 0.022. I just like things to be consistent. Kind of robot-like in that. It says in a random sample of 300 adults, what is probably that less than 16% have no credit cards? So less than 16%. So they're giving us p hat. They're giving us p hat is equal to 0.16, and less than would be shaded this way. This is going negative E99. Okay, so let's look at our step 1. Find your mean standard deviation. We did that. Step 2 is we need to convert it to a z-score. So we got z is equal to p hat minus mu sub p hat over sigma sub p hat. I'm gonna go with the 3 decimal places for standard deviation. We may get it wrong though. P hat was 0.16 minus mu sub p hat, which I have no clue, 0.17. No memory. Over sigma sub p hat, which is 0.022. Since there's more than a single number up on top, when I enter in, I got to put parentheses around top. Let's just see if it says. Doesn't say anything about that. Okay. I'll get to the calculator here eventually. There we go. So I'm going to do a beginning parentheses, 0.16 minus 0.17, close parentheses, divided by 0.022. And we want to take it to 2 decimal places, so we got negative 0.45. Okay. Step 3. Now our picture now has become, instead of p hat down there, we got z equals. Z equals negative 0.45, and we're shading to the left. Again, that's negative E99. The one that's going negative E99 is our second case in step 3. So we're going to use normal CDF, negative E99, comma, negative 0.45, comma, 1, comma, 0. The 1, or 0, 1, true. 0, 1. So we got second, bars, normal CDF. I'm actually waking up now. This has kind of woke me up. second comma 99, which is good because I have to get on for my own graduate course that I'm taking, comma 0, comma 1. In 4 decimal places, we get 0.3264. 0.3264. 0.3264. Okay. Last part. It says, this is C. Would it be unusual in a random sample of 300 adults results in 60 or more having no credit cards? 60 or more. So given us x is equal to 60 or more shaded this way. So it's going to E99. Now we're going to need it eventually because we have to have it in form of p hat. P hat is equal to x over n. So we're going to have 60 over n, which was sample 300. What's that equal to? I know it comes out nice, so I shouldn't have to do this, but sun's in my eyes, that's why I have to look it up. 60 divided by 300, 0.2. So p hat is 0.2. Well, we have to convert to a z-score. So z is equal to p hat minus mu sub p hat over sigma sub p hat. P hat we just said was 0.2 minus mu sub p hat, which we said earlier was 0.17, over sigma, which is 0.022. Again, when we plug this in the calculator, we're going to put parentheses on top. So I got beginning parentheses 0.2 minus 0.17, close parentheses, divided by 0.022. And 2 decimal places, we get 1.36. Is that positive? Yeah, it is. Okay, so our picture has now become, instead of x equals, we have z equals 1.36, and we're shading to the right. And clear over here is E99, so we want the form that's going to positive E99, which is our first one. So we'll do normal CDF, 1.36, E99, and I think 0.1, yeah, 0.1. So I'll do second vars, normal CDF, 1.36, 1.36, comma, second, comma, 99, comma, 0, comma, 1. Enter. And we get 0.08, 0.0869. Now it's not less, let me get back to there we go. It's not less than 5%. So the result is unusual, no. Result is unusual, no. So it's the bottom two. It's not unusual because it's greater than 5%, which is the last one, I guess. So let me submit the test and we'll see how many I missed. This is the depressing part. Unless I get 100, then I'll celebrate. Alright, every one of them correct. I just got lucky. So I was kind of tired when I started this, so I wasn't sure. What do I need to do? Go to the results, I guess. I don't know what that did. Somebody asked about one of the problems earlier, so I went through and I didn't get 10%. I just only worked one problem. So, hour and 12 minutes. Not too bad. Anyway, that's the Chapter 7-8 test review.